limit at infinity. Now let's say we have a function given like this: limit x approaches infinity. The function is given like 8x squared minus 5x divided by 4x squared plus 7. So here you can see that first we cannot direct substitute because we are going to get infinity over infinity, since we have the power same in the numerator and the denominator. So we have to do something else. Also, like whenever we have a x power, if it's equal in the numerator and the denominator, what we do is, to simplify this one, we can multiply by 1 over the higher power. So here the higher power is x squared, so I'm going to multiply this one by 1 over x squared in the numerator and also 1 over x squared in the denominator. And if I simplify this one, 8x squared times 1 over x squared, that's going to be 8, and then minus 5x times 1 over x squared, that's minus 5 over x, and 4x squared times 1 over x squared, that's going to give us 4, and then plus 7 over x squared. And if we divide anything by infinity, that's going to be 0. So here 8 minus 5 over infinity, if I substitute this one, and make sure you write limit here as well because we didn't substitute infinity yet. So I'm going to write limit x approaches infinity here, and the next one I'm going to go ahead and substitute. If I substitute, this 5 over infinity becomes 0, so this is 0 right here. And then 4 plus, again, if you square an infinity, that is also a huge number, so 7 over infinity, that's also 0. So finally we are getting 8 over 4, that is equal to 1 over 2. Okay. No, not 1 over 2, actually 2. 8 over 4 is 2. Okay, that's our final answer. Let's look at another example. Let's say we have a question like this: a limit x approaches negative infinity, and then the function is 5x minus 7x cubed divided by 2x squared plus 14x cubed minus 9. Again, we have the same power, like we have x cube here. So if we substitute infinity, this is going to be infinity over infinity. So we don't know what, we cannot find the answer. So we have to simplify this one. To do that, I multiply by the reciprocal of higher power. Here x cube is the higher power, so I have to multiply the numerator and the denominator by 1 over x cube. So it's going to be 1 over x cube multiplied by this, 1 over x cube multiplied by this. And if I simplify, this is going to be limit x approaches negative infinity, and 5x multiplied by 1 over x cube, that's going to become 5x squared, and then minus 7x, 5 over x squared, not 5x squared, 5 over x squared, and then 7x cube multiplied by 1 over x cube, that's going to give us 7. And in the denominator, we are going to have 2x squared multiplied by 1 over x cube, that's going to give us 2 over x. And then 14x cube multiplied by 1 over x cube, that's going to give us 14. And then 9 multiplied by 1 over x cube, that's going to be 9 over x cube. Now we can remove all the numbers that's dividing by x values, because we are dividing a number by infinity, so that's a larger value. If you divide any number by large value, that's 0. So here we can cancel this one. This one becomes 0, this one becomes 0, this one becomes 0. So finally we end up with so make sure, like, if I'm substituting, I had to remove the limit as well. But I have the x here. You had to, it's better to show in one more step, so I'm going to write one more step here. Limit x approaches negative infinity, and then, okay, you know what, since I'm substituting, I don't need the limit anymore. I remove this one. So here is going to be just 0 minus 7 divided by 0 plus 14 minus 0. So that's negative 7 by 14, and that's negative 1 over 2. And that's our final answer. Let's look at another example. I'm gonna go ahead and erase everything. Okay, let's try this one. Let's say we have a limit given like this. Limit x approaches infinity, 5x plus 6x squared over 3x minus 8. So there are multiple different ways you can approach this problem. Let's look at the first one. First one is direct substitution. You can only do the direct substitution if you have one of the x power is higher than all of them. So here you can see 6x squared is higher power than most of them, right? So this is going to be infinity on the top. So that's definitely the answer is infinity. But there's another way, like if you want to prove with the steps, you can do one of these. Like you can say, like in the numerator, you have to look at the insignificant insignificant values. What do I mean by insignificant values is when you have lower power, like you have to just leave the higher power alone and cancel all the lower power. You can only do this when you have infinity. So here 5x, I can cancel this, and negative 8 in the denominator, 3x is the highest power, so I can cancel this negative 8. So we get we can rewrite this one as limit x approaches infinity, 6x squared over 3x, that is equal to 2x, right? So if I simplify this one, this is going to be limit x approaches infinity, 2x. And if you now we can substitute 2 times infinity, that's infinity. Okay, so this is one way to do it. Now the another way you can do it is you have to look at what is the common highest power in the both, like you have to look at numerator and the denominator. Here we have 5x plus 6x squared, but in the denominator we have 3x minus 8. So in the denominator we have only x, right? If we have x squared, we have to multiply by 1 over x squared. But since we have denominator only with x, we don't have x squared here. So we can divide the numerator and the denominator by, like we can multiply the numerator and the denominator by 1 over x. Let's go ahead and do that. So limit x approaches, let me use a different color. Okay, limit x approaches infinity, and then here I have like 5x plus 6x squared. In the denominator I have 3x minus 8. So I'm gonna go ahead and multiply 1 over x, the numerator and the denominator. And if I simplify this one, this is gonna become limit x approaches infinity, 5 plus 6x divided by 3 minus 8 over x. And whatever the values that dividing by x, we can say it's 0 because we are dividing a number by infinity. That becomes 0. So we can say this one, limit x approaches infinity. So if I'm substituting, I don't have to write the limit anymore. So don't write limit here, just directly write it. Okay, so here if I write it, this is going to be 5 plus 6 times infinity divided by 3 minus 8 over infinity, that's 0. So I can just say 0 here instead of multiplying, dividing. So I can say 0. This is going to be what? We are having 5 plus 6 times infinity divided by 3 minus, we can just say 3 here. Okay, so 6 times infinity is infinity. So let's write this one. You know, you cannot divide or add before you simplify the infinity term. So let's go with the infinity first. So 6 times infinity is infinity. Then if you add 5 to that, so you are adding a 5 to a larger number, that's still infinity. So infinity, and if you divide infinity by 3, nothing happens because you are dividing a larger number, that is still infinity. So the final answer is infinity. Okay, let's look at one more problem. Yeah, let's look at one more problem. I'm going to erase the whole thing. Okay, let's say we have a question given like this. Limit x approaches infinity, and then 5 plus 2x minus 3x squared divided by 4x squared plus 9x. Okay, what we can do here, as we did in the previous question, what we can do is we can actually remove all the insignificant terms. What do I mean by insignificant terms is whatever the terms that is less than the higher power. So here in the numerator we have 3x squared. X squared is the higher power, so we can remove 2x, 5, and in the numerator we have 4x squared. X squared is the highest power, so we can remove this 9x. If we do that, we are going to end up with limit x approaches infinity, negative 3x squared divided by 4x squared. Now here we can cancel the x squared, that's equal to negative 3 over 4, and that's our final answer. And that's it for this video, guys. Thanks for watching. See you guys on my next video.